everyone. This is Kumar. Welcome to the channel. Today I would explain about implementation of using it is another way implementation is defined by its pro- property of means first and first out. That is the element which is added first is taken out. It is a basic rule of the queue. The first element added in the first element being removed. And we have implementation of the function unqueue and dequeue. To enable this behavior, we can say that we have implemented a queue data structure. Means the unqueue function are using insertion of an element into queue and dequeue function to perform remove from the queue. The two basic functions of normal queue. While implementing a queue data structure using stacks, we will have to consider the natural behavior of stack to which is first in last out. It is entirely different operation is the normal. For performing NQ, we require only one stack as we can directly push data onto the stack. But to perform DQ, we will require two stacks because we need to follow queues FIFO property. And if we have directly pop any data element out of stack, it will follow LIFO approach, that is last in first out. This is the major and important point because of it is in a queue implementation using stacks. Generally, the queue is implementation using normal orders before means first in first out. In general, the stack operations, the lost in first out object. The both are different and opposite operations. But in this implementation queue using stacks, that's why the NQ operation it performed using one stack. It means the NQ operations performing using stacks and DQ operation performing two stacks because of the normal queue first in first out operation. Using stacks also the main rule is first in first out, but using stacks the last in first out order. That's why the first stack elements are moved to the second stack two elements. That's why the DQ operations using two stacks. For example, it is a one stack. For example, P4 in a stack 1. In case it can perform dequeue operation, the stack 1 values are moved to stack 2 array. In this stack, in general, the last and first, that is the fourth is moved to the stack 2, and next element is moved to the stack 2, and next element moved to the in this as stack 2 removes the top of the stack, that is 2. So it is a first stored element in the queue. That is the performing dequeue operation. That's why using two stacks. Otherwise, the first element cannot delete. So the queue general, the first in first out order. So at the same using two stacks, the first element is okay. The implementation of queue can be done using two stacks. Queue using stack can be done in two ways. Making the unqueue, that is the insertion operation. The another one by making the dequeue deletion operation. The unqueue is generally using for the insertions, dequeue is using for the removing of. Implementing queue using stack by making the unqueue operation. Initialize stack on stack 1 and stack 2, making top 1 equal to top 2 equal to minus 1. So by default, the top is representing minus 1. The initial value is the minus 1. To perform an unqueue operation, push all the elements from stack 1 to stack 2. Push the new element to stack 2. Pop all the elements from the stack 2 to stack 1. To perform dequeue operations, pop and return the element from the stack. This is the one type of unqueue operation. This is the algorithm of the stack by making the unqueue operation. Another one, queue using stack by making dequeue operations. Implementing queue using stack by making the dequeue operations. Initialize stack 1 and stack 2, making top 1 equal to top 2 equal to minus 1. So by default, the initial state is the. To perform an unqueue operation, push the element to be added to the stack 1. To perform dequeue operations, push all the elements from the stack 1 to stack 2. Then pop the top of the stack and return the element from the stack. This is the dequeue operations using.